Sine of 0 is 0, so we get 0 over 0. Is it sine of junk over junk? Well, not really, because these don't match, do they? Over here they didn't match either, right? But we remedied that by noticing the bottom was a difference of squares, and then we were able to do this, right? We have a little bit of an issue, though. The difference of squares is inside the sign this time. So can we do this? Tell me if I can do this, if this is fair. Am I allowed to do inside there? Could I do difference of squares? Oops. Could I do difference of squares in here like that? Like algebraically, have I done anything wrong there?
No.
No, that's okay. But this junk is still not the same as this junk, because that's there, right? That's there, that's, it's not down here. So I think what was asked is, can you do this? So I'm going to put this on the side. Let's not put it over here. This is a question. Are you allowed to do this? Is sine of x plus 2 times x minus 2 equal to sine of x plus 2 times sine of x minus 2? I'm not sure if that's what you were asking me, but what do y'all think? Are you allowed to do that?
Yes.
Yeah, in pre-cal, there's nothing that allows us to split a sign up like that. Because the sign is not something you can distribute through parentheses like that. The most we ever have in pre-cal is something like this. If we have a sum inside the sign, then there's a formula to break this down with sines and cosines. Sine x cosine y plus, does that? It's your sum and difference formulas. So I'm not going to use that. This is not even addition. See, it's multiplication inside. So there's this no, can't do it. All right? Unfortunately, cannot do that. So there's no way to split this up. So it looks like we might be stuck, right? What would we love to have down here? What would solve our problem? What would make this doable if I would have had what down here? X plus 2, right? That's what I need down there, right? So I'm going to make it appear. Right? Here we go. Magic. I'm going to multiply by 1. But the 1 I'm going to multiply by is x plus 2 over x plus 2. Why am I doing this? Because it's what I need, right? I'm fixing a problem. The problem is I really wished I had an x plus 2 down here. Then I would have the same junk, wouldn't I? And so you look at that and you're like, wait, that doesn't seem fair, right? To do that? Watch though, just watch. So I'm going to rewrite this. I'm going to have the sine of the x plus 2 times x minus 2. And then over the, I'll put them together, x plus 2 times x minus 2. So what I did was, because this is multiplication, I slid this one over here to the side, underneath next to this one. What do I still have out here though? X plus 2 on the top and on the bottom? 1, right? So this is really just next to an x plus 2 that was on the top over a 1. I'm manipulating the fraction. When you have fractions with multiplication, you can slide things around. It's called the commutative property of multiplication. So I'm just being clever in a way, right? This is a little bit, I'm trying to be clever. Yeah, I don't know another word for it. So now, have I created sine of junk over junk where the junk matches and it goes to 0? Yes? Can I look at this one, do this limit by itself, and then do this limit by itself? Yes, limit laws allow me to do that. So when I take this limit, this goes to 1 times, and I do this, I let x go to 2, and I get 4 over 1, which is 4. So my answer is 4. Yeah. So remember I said algebra tricks? There's a trick, right? I introduced the thing I needed, right? I thought about what would make this thing work if I had an x plus 2. Okay, let me introduce it on the top and bottom. All right, let's do another one. How about this? Limit, let's go x goes to 0. Let's do sine of 5x over tangent of 3x. Now, historically speaking, I've been teaching Cal 1 for a while, students really do not enjoy this little section about the sine junk over junk. A lot of students don't like it, and I can understand why, because it's not as direct and straightforward as a lot of other things are. You have to really kind of think about what you're trying to achieve, all right? So let's take a look here. We've got limit x goes to 0, sine of 5x over tangent 3x. So let's just try and plug in. X goes to 0, 5 times 0, 0. Sine of 0, 0. So the top goes to 0. The bottom, 3 times 0 is 0. Tangent of 0 is? 0. It's 0. But just in case you forgot, this is what tangent looks like. Pre-cal. Right? This is pi over 2. This is negative pi over 2. And it's periodic. It keeps repeating itself like this. But the important thing is that at 0, the tangent function is 0. It goes through the origin. So you need to know that. So you get 0 over 0, right? So that's bad. So it needs some algebra. Is that a question? Yeah, so what do we do now, right? What algebra are we going to do? One suggestion here is, hey, isn't tangent sine over cosine, right? Isn't it? Okay, so when you see a problem like this, where you've got sines and tangents, things like that, and you're doing a limit and you're getting 0 over 0, here's my recommendation. Rip everything apart, right? And this is what I mean by that. Just follow me through this. I'm going to rewrite this as sine 5x over 1 times 1 over tangent 3x. That's my first step. All I'm doing is pulling those two fractions apart into two different fractions. Is that fair? Okay, and 1 over tangent, you have to know, again, what tangent is. I'll write it on the side here as a reminder. Tangent of x is sine x over cosine x. Right, that's the definition of tangent. So 1 over tangent of x would be this flipped over, is cosine x over sine x. It's the reciprocal, right? So that means I can rewrite this as, I think I'll put it up here because I need some room. Limit x goes to 0. All right, I have sine 5x over 1 times this right here becomes this, right? But with 3x instead of x, yes? Cosine 3x over sine 3x. That's me rewriting 1 over tangent 3x. Any questions there? Are you sure? Everyone's good? All right, I'm not done ripping things apart. I'm going to continue ripping things apart. I'm coming back over here. Equals limit x goes to 0, sine 5x over 1 times cosine 3x over 1 times 1 over sine 3x. All right, all I did there was this last fraction. I ripped it into two fractions. I've done nothing in terms of solving the problem. All I've done is rewritten it, right? This was all just to rewrite it. Now what I'm going to do is I'm going to look at this and I'm going to ask myself, where am I having a problem? Like, where's the problem, right? Where's the issue coming from? Well, if I let x go to 0, we already said sine of 0 is 0, right? 0 divided by 1, is that a problem? No. 0 divided by 1 is 0. Okay, so that's not a problem. What's cosine of 0? 1. What's 1 divided by 1? 1. Is that a problem? No. Okay, so far it's 0 times 1. Then I get to here and it's what? 1 over 0. That's a problem, right? That's a problem. So I've identified the piece that's causing the problem, right? That's causing the issue. I'm like, okay, shit, I don't want that there. That's a bad thing, right? But using this whole idea of the junk thing and the sign, right? Wouldn't it be just absolutely great if I had a 3x up here? If I had 3x right there, if that was a 3x, then this would be sign junk, junk on top, the junk matches. It would be going to 0, wouldn't it? X goes to 0, so 3x would go to 0. Wouldn't that work? Remember I said that formula, you can flip it over. So do you all agree a 3x up here would make this turn into a 1 when I take the limit? Okay, so I need to put a 3x up there. But you can't just like arbitrarily just walk in there and just write 3x, right? The only thing you can ever do is multiply by 1. So I'm going to do that. Right over here next to it, I'm going to multiply by 3x over 3x. Now, because this is all being multiplied together, and multiplication is commutative, which means you can slide things around, I'm going to choose to take this 3x and drop it right up here. Okay? So when I do that, I remove it from here. It becomes a 1, right? That's a 1 right there. And then this becomes a 3x. You don't see it? I'm allowed to do that. Now let's run through everything and check again what happens. This is 0 over 1. That's okay. This is 1 over 1. That's okay. This is now going to 1 because of the whole junk, sign junk matches, everything's beautiful, right? So far I'm like happy, I'm all elated, and then I get to this. This is 1 over 3 times 0 is 0. 1 over 0 is a problem, right? So it's almost like I fixed one problem. I plugged one hole in the boat, right? The water was coming in. I plugged the hole, and I turn around and I've got a new hole, right? That's exactly what I did. So seems like we're not getting anywhere because of what's really causing the issue is that x right there, right? The 3 doesn't matter. It's really the x. So then I do something extremely clever. I realize I have a sine of 5x over here. And even though it's not a problem, right? This is not a problem. 0 over 1 is not a problem. If there was a what here, it would turn into 1. If there was a 5x. Wonder if I have any x's floating around. Do I? Yes. Down there, right? I have 3x. I'm actually going to grab just the x. And I'm going to slide it all the way down here and put it right there. Almost there. I'm missing a what? A 5. Can you introduce a 5 down here? If I introduce a 5 over 5, I can. So back here on the end, I'm going to introduce a 5 over 5. That's a 1. I can do that. And then I'm going to take just the 5 that's down here and slide it under here. And that's going to, well, it's going to go away here. The 5's going to go away here. This is going to become 5x. I realize this is strange because it's not a very natural thing. It's, you're trying to massage this thing to get it to work.
Yeah, like is there a name for this so that I can...
No, and I'm really disappointed in the book. The book only gives you 4 examples of this. In the calculus book I learned out of, there was like an entire section of just problems like this, just so you could do them. There's no name for it though. All right, let's check everything. Let's see if we actually have good things happening. What is the limit? If I take the limit of this now, what does it go to? 1, right? This one? Cosine of 0 is 1. 1 over 1 is 1. Times. This one, which was my original bad thing, right, that I fixed, that goes to 1. Okay, what's still here? The 3 on the bottom, right? And then we had a 1 on top. So I have a 1/3 there. And then times over here, I pulled the 5 on the bottom over, right? But I left the 5 on the top. So I still have a 5 up top, don't I? So I'm just going to put 5 here. And there's no problems anymore, right? This all goes to what? 5/3. Yep, 5 over 3. It's weird. I get it. It's weird. And that's why I told you when I started that students historically don't care too much for these because it's not like a simple just, you know, monkey see, monkey do, I do, you do, right? You have to actually think through what you're trying to achieve. Let's do one more. Did y'all notice that the answer was 5/3? Well, yeah, it would have been on that problem, but not every single problem is like that. One more. So let's do tangent of pi x over, let's do tangent of 5x on the bottom. X is going to 0. Now I'll just give you a little, well, I won't give you anything. Let's just keep going. So what do we get when we let x go to 0 here? 0 over 0, right? So we got to do some algebra, right? So I'm going to start ripping everything apart. So I'm going to go limit x goes to 0. I'm going to go like this, tangent pi x. Isn't pi just a number? Right, it's a constant, right? So this is a number in front of x. And then times 1 over tangent of 5x. So I pulled those apart. And tangent, by definition, is sine over cosine. So this is limit x goes to 0. Let's see if I can do this, or if this is too much. So that right there is sine over cosine, right? Sine pi x over cosine pi x. But I'm going to rip that apart because I know ultimately I want to rip everything apart. So that's just this one. And then this one, remember we showed a second ago, is not sine over cosine. This turns out to be cosine over sine. So I'm going to write cosine 5x over 1 times 1 over sine of 5x, like that. Any questions on where I got all that? All good? Y'all are happy? No. Okay, you don't have to be happy, but you understand? Yes?
So you just broke it, like the 4 at the bottom, you just broke apart the first one and then the second one?
Yeah, this one right here is sine over cosine, right? So that's your sine over cosine, but I just pulled them apart. And then this one turns out to be cosine over sine, and then I just pull them apart. And I just always, in these problems, I like to pull everything apart so I can identify where the problem is. All right, is this a problem? No, right? Well, pi times 0 is still 0, so sine of 0 is 0. 0 over 1 is 0, so that's okay. 1 over cosine of 0 is 1. So 1 over 1, that's 1. Okay, cosine of 0 is 1. 1 over 1, 1. And there's the problem. There it is. At the very end, we get 1 over sine of 0, and sine of 0 is, division by 0 is undefined. So this is the culprit right here, right? That's the one causing the issue. So how do I fix it? I need a 5x on top. But if I put a 5x on top, I'm going to need a 5x on the bottom as well. Right? I will have to take this 5x, and I will dump it right here, right? I'll dump it on the top there. Make that 5x. That'll become a 1 there. I have now fixed that problem, right? This is no longer an issue. This goes to 1. But again, I've created a problem here, haven't I? Because I get 1 over 0 again. So I look throughout the problem somewhere else and I see, is there anywhere where I wish, well not wish, but that I could use that x? Right here, right? You could put it right here. I would just also need a what there? A pi, right? I would need a pi as well. So I can make a pi happen. I can make a pi happen easily. I'm going to do it right here. I'm going to do times pi over pi. And I'm going to take this pi here and that x, just the pi and the x, and I'm going to go dump them over here. Pi x. The x is gone. The pi is gone. Everything should work out now. We should have no problems now. Take the limit, let x go to 0. This right here is sine junk over junk. Junk matches, junk goes to 0, that goes to 1. Times 1 over cosine of 0, that was 1 over 1. Times cosine of 0 is 1, 1 over 1 is 1. Times junk over sine junk, junk matches, junk goes to 0, 1. Times over here, I had the 1 on top and the 5, 1/5. And over here, I had the pi. So your answer is pi over 5. Which again was that, right? Pi over 5? It's not every time. So on your test, I want to see you do some work. I don't want you putting just pi over 5. Because I could give you a problem where it doesn't work and then you get it all wrong because you didn't want to go through the mess of it. All right. Now, there's another formula that we haven't even talked about, right? There was 2 formulas that you should know. So on the other one, I'm just going to show it to you, and we're not going to work through any examples on it, because this is the one that comes up most frequently, right? This is the one, the sine junk over junk. But a similar formula is that cosine one, and it looks like this. If you have a limit, doesn't matter what this limit is, if you've got cosine junk minus 1 over junk. If this junk matches, the junk goes to 0, then the answer is not 1, the answer is 0. And you are not allowed to flip that over. Okay, you cannot flip that one over. That one has to look exactly like that. All right, I'm going to do one last problem. I usually leave this problem as a challenge problem. It's a homework problem, but again, in my experience, I wind up having to show this in class anyway. So I'm just going to go ahead and do it. It's this one right here. So please understand, this is a challenge problem, meaning that I probably would not give you something like this on a test, but it is worth seeing it, or else I would not have put it in your homework, or like in this case, I'm doing it in class so you can see it, all right?
Which number is it?
This is actually number 55 from 1.4, which I didn't tell you to do this last time. I cut you all off, I think, at what, 18 or something, or 28? 28. Yeah. 28. So the homework for this section is now going to be, the rest of the homework for this section is going to be 49 through 56. So for 1.4, it's going to be 49 through 56. That's what's left, along with what I gave you last time. Now you can do these. All those problems involve this whole sine junk thing. And this is number 55, so you won't need to do it. All right, let's see what's happening. Theta, we're using theta instead of x. Theta goes to 0. Sine of 0, 0. Top goes 0. That by itself is not bad. It's if we get division by 0. Theta goes to 0. That's 0 plus, what's tangent of 0? 0. 0 plus 0, 0. Now, that is a problem now. Can you split this into 2 fractions? Can I go sine theta and split it and then do sine theta over tangent theta? Are you allowed to split that way? No. If you have 2 terms on the bottom and 1 on the top, you can't split. If it were flipped the other way around, we could, right? If it was the other way, then we could do it. But because it's 1 term on top and 2 on the bottom, we can't. So, I mean, you could sit here for a long time trying to figure this one out. So anyone have any ideas of what they want me to do? I mean, just someone got to go somewhere with it. Separate how? What do you mean? So sine by itself over 1? Is that what you want? Sine theta over 1. And then that means the other one would have to be 1 over theta plus tan theta. Is that what you meant? Yeah. That is a legal move right there. I agree. We can do that.
You could separate the theta plus tan theta, but it would have to be added into separate fractions.
Can you?
Um,
Are you allowed to do that? Can you split that? So back when I was, a student of math myself, I would run into things like I wasn't quite sure about. Could I do it or not? So the thing I did a lot as a student is I gave myself examples to see if it works. So I do something like if I put 4 over 1 plus 3, right? So I have like something over 2 things added. I want to know, can I split that into 2? I'm not sure if this is what was being suggested, but can I make that 4 over 1 plus 4 over 3? Well, I don't think so, because what's 1 plus 3? 4. And what's 4 over 4? Is 1. So the answer should be 1, right? This is not 1. So this must be not allowed, right? I mean, that's,
right.
so it's not, right? Now, does it work the other way around? If I do 1 plus 3 over 4, can I split it? So the question is, can I split this? 1/4 plus 3/4. Yeah, that is 1, isn't it? And so is that. So unfortunately, we can't split this into 2 fractions.
Put sine theta over cosine theta, replace that with tangent.
So you want to replace tangent with sine over cosine? I'll do that. To save myself some time, I'm just going to do it like this. Is that legal? Yeah, I can do that. I'm not saying it's going to make life any better, but yeah. Yes?
Maybe multiply the top and bottom by cosine.
Which one? You mean this fraction right here, just multiply by cosine top and bottom? Can we do that? Are we allowed to? Because cosine over cosine is 1, right? I'm allowed to do that. You want me to do that? Okay, I'll do it. It's not illegal, right? I mean, as long as I do algebra and don't break any rules, then nothing I'm doing is, if nothing I'm doing is illegal, then I'm allowed to do it, all right? Again, not necessarily sure it's going to get me anywhere, but let's see. So it's being suggested that we do cosine theta over cosine theta. And I think maybe the thought of this is that this cosine is going to distribute, and then it'll cancel on this one. Is that what you're thinking? Okay, it will. Let's see what goes on here. So hit this up top with cosine theta. On the bottom, you have to distribute. It's like this is in parentheses. So this times this would be theta cosine theta. That does not become cosine of theta squared. That theta is trapped in the cosine, so that theta just sits in front. And then here to here, do y'all see the cosines go away? And you just get plus what? Sine theta.
Did you multiply the cosine top?
Here?
At the
Through here?
Yeah.
It went through, you're looking at it as like a cosine over 1. So when it comes through here, it's going to be on top of this cosine. That's legal. That is still the same problem. We have not changed anything. Everything's good. But I don't know if we fixed anything. Theta goes to 0. We get 0 over 1. Theta goes 0. What's cosine of 0? 1. Okay, 0 times cosine of 0. That's still 0 plus that's still 0. So we still have division by 0. So I'm not sure if you had like a grand plan or something, so do you want me to keep?
Instead of doing that, could you multiply by theta over theta?
Right here, do theta over theta instead? You could.
Could you not cancel out the sine thetas?
Here and here, you couldn't because this is separated by addition. If this was multiplication, then absolutely those would go away. But because it's addition, we can't.
And then put one theta on top and one theta on bottom.
So you're talking, instead of doing this, having done theta and theta here? Is that, yes? And then the theta would come here, and then on the bottom, it would come through and become theta.
No, on the under.
Oh, underneath.
No,
Oh,
the left fraction.
oh, over here.
Yeah.
Oh, I'm sorry. I thought you were talking about here. So this is an idea. So if we did, you're saying theta over theta, you want to put theta over theta, you want to put the theta here, and then you want to put the other theta under this one. Could we do that?
Yes.
Do y'all want me to do that?
Yes.
Yeah? You want to try it?
Yeah.
Okay, do y'all want me to stick with this or go back and go to where we were?
Go back.
It doesn't matter where we go. I mean, this like I said, this is not an easy problem. It's not obvious what to do. right? So let me do this because time, right? Because of time in this class. The theta over theta is not going to work because of this. When we do theta on top, right, that becomes a theta. And then the theta under here, that will become a 1. That's sine junk over junk. That's great. But this is still 0 over 0. Yes? Okay, hold on though. I want everyone to see that this is still 0 over 0. That's 0. Then 0 plus, that's 0 over 1. So this is 0 plus 0, 0, 0 on top. That's still 0 over 0. It's still a problem. I like the idea that you're seeing that you're trying to use that sine theta against itself there. That's good, but it didn't help. So I'm going to go back to this. And then someone else has an idea here. So let me go back. This is where we were, right there. So we've had two ideas, cosine theta top and bottom, and then theta top and bottom. And now,
It's a different idea entirely. So it's like already at the beginning now.
okay, tell me what it is and I'll,
If tangent is sine over cosine,
Mhm.
and you say sine is cosine times tangent, so you can replace the top the numerator with cosine times tangent and then cancel the tangents. Or
because of the addition, you wouldn't be able to cancel, right? Again, it's that addition right there that causes the problem. Yeah. All right, so in an effort to save us time, right, I'm just going to show you how to do this, right? So the theta over theta was almost it. It was almost it. It needs to be 1 over theta over 1 over theta. All right? Now let's see why. Let's see why. So I think this is a good example of a problem where with enough persistence, you could get it. And this word persistence, right? You'll know what that word means? Persistence? You know what it means? When I think of the word persistence, I think of somebody who's just annoying. Like they're just like persistent. They just don't stop. They just, just will not relentless, right? Persistence is something that in this class is very beneficial to you, but in Cal 2 is absolutely essential. You have to be persistent. You're going to get things wrong way more times than you can get them right in Cal 2. And it's all those mistakes you will learn from. So here is a good example of a problem where you either are going to be the type of person that says, I can't figure it out, I don't care, or you're one of those people who are like, I'm not going to bed until I figure this out. And that's really kind of where you have to figure out what you are, right? Are you the person who, like a lot of you are engineering majors, computer science, right? So when you are faced with something difficult, do you cower away from it, or does that actually motivate you to go after it more? Because that is ultimately what in education, what we're trying to achieve, right? We're trying to get somebody